test, nothing like that. So, this first one here, I wanted you to find the one that would fit, that would go from greatest to least. Now, if you look, this is 4.5, 9 over 3. If you divide that, it's just 3. Negative 8 over 4, well, that's just negative 2. Okay, and then we go bigger negatives, because the further we go from 0, all right, the bigger the negative it is. So in reality, because I changed the question, both of these answers would actually work. Because this would be negative 2, this is negative 3.7. Well, negative 2.8 is further away from 0 than negative 2. Negative 3.09 is closer to 0 than negative 3.7. So both of those would work for this situation. Number 2. Which statement best represents the integer negative 12? Well, if you're negative, it's either going to be going down by something, you're pulling money out, doing something like that. Well, in this case, the only one that you withdrew or went down anything is letter B. Rachel withdrew $12 from the ATM. It means she's taking money out of her account. Number 3. Fernando read the current temperature on his smartwatch. It stated negative 3 degrees Celsius. What is the absolute value of the temperature? Okay, remember, absolute value is the distance away from 0. So, the absolute value of negative 3 is just 3. Positive 3. Absolute value is always positive because it's the distance away from 0. Number 4. Which of the following numbers is greater than 1 1/5? So you could change these all to decimals, you could change them all to fractions. I'm going to change them to decimals. So what you have to do for the decimal part is just divide the numerator by the denominator, top by the bottom. Decimal to 0, well, 5 goes into 10 2 times. So this is 1.2. So we already have 1 as a decimal, now we just change the other ones. Well, 3 divided by 2. 2 goes in there 1 time. And then it goes 1.5. And then this last one is 1 1/8, so you just got to divide the 1 by 8. It's top divided by the bottom. So 8 goes into 10 once, twice, maybe 4. And it goes in there 5. So this is 1.125. So now we're looking for a number that's bigger than this one right here. Well, the only one that fits would be this one right here, letter C, 3/2. So it does not matter. You can change them all to fractions. You can change them all to decimals. But you're going to have to get them to be all the same so you can compare them. All right, number 5, Logan and Santiago plotted the negative 2.5 on the number line. Whose represents the correct location? Well, if you look, negative 2 and then negative 3 is right here. So they went halfway. Well, that's negative 2.5. So Logan's right. Now, if you look at this one, they took some extra ones, but this is technically negative 1. This is negative 3. So that's in between negative 2 and negative 3. So they're both right. You have to pay attention to the numbers they use on the number line. Number 6, Marshall is asked to locate the point negative 4/3 on the number line. Which point best represents? Well, everything to the right of 0 is positive, so automatically I know it can't be point D. It's got to be one of these. Well, negative 4 1/3. If you look, in between each number, they're going 3 numbers because of the fraction. So this is technically, as a mixed number, 3 goes into 4 1 time. I have 1 left over. This is negative 1 1/3. If I go right past negative 1, it's point B. Is that negative 1 1/3? Point B. Number 7. Which inequality represents the statement 0 is located to the right of negative 5? Well, 0 is going to be greater than negative 5 because it's to the right. So it's letter B. Number 8. Leah wants to buy parking passes. So they want you to write these from closest to furthest. That means least to greatest. So one's a decimal form and the other two are fractions. So what you could do is you could change all three to be fractions, or you can be all decimals. I'm going to change them to be decimals. So 0.54 I'm leaving alone. 5/8. 5 divided by 8. Well, decimal and a 0. 8 goes into 50. 6 times, that's 48. Get 2 left over, drop another 0. 8 goes into 20. 2 times, that's 16, we get 4. So this one is 0.625. And then 2/5 is 0.4. Okay, so I like to add zeros to make them all line up to have the same amount of numbers. So now we're looking at this as 540, 625, 400. Well, the least would be this 400, that 2/5. So that one's done. The next one would be the decimal, 0.54. And the last one is the 5/8. You have to use the original numbers. So those are the numbers you would put in order. Okay, so that's the front. Let's go on to the back page now. Number 9, which of the following is not true about the number given? Well, it's negative 18. Well, the number isn't negative. It's 18 away from 0. The absolute value is positive, but the opposite would be a positive. So it's letter D. Okay, Elias, I don't even know, argues that the absolute value of negative 12 is less than the opposite of 18. So they want to know if this is correct or not. Well, the absolute value of negative 12 equals positive 12. He said that's still less than 18. Or the opposite of 18. Or what would be the opposite of negative 8? Or the opposite of 18? What? Negative 18. So is 12 less than negative 18? No, so he's incorrect. Incorrect. Because 12 is greater than negative 18. So he is incorrect. The absolute value of negative 12 is 12, and the opposite of positive 18 is negative 18. So 12 is always going to be bigger than negative 18. Number 11, the table shows the average temperatures for 5 states. They want you to pick which one is ordered from least to greatest. So if you look, the very least is negative 8. Then we have negative 3, negative 1, 5, and 12. So we got to start with Minnesota and then go to Illinois. So the only one is letter D. Number 12, which of the following lists the rational numbers from least to greatest? So I would change all these to be decimals, is what I'm going to do. So each number has the same, or each one has the same numbers. So I'm going to change negative 4 3/4 to a decimal. Well, the negative 4 goes in front. The 3/4. I know 4 goes into 100. That's 25 times. So this would be 75. 4 and 75 hundredths. Okay? Negative 4.35. That's already a decimal. You don't even have to mess with it. Negative 12 over 3. If I divide 12 by 3, what is it? Divide. Remember, fractions always just mean divide. Negative 4. 12 divided by 3 is 3, or 4, and then you can put the negative. Now, 15 over 4, we're going to have to divide. So 15 is on top, 4 is on the bottom. Top divided by the bottom. 4 goes into 15 3 times, not 4. So you get 3, drop a 0, that's 7. Drop another 0, that's 5. So So we get 3.75. So we are starting from least to greatest. So these three are negatives. This one's a positive. Automatically, I know that 15 over 4 has to be at the very end. Then I'm going off what would be the farthest away from 0. Well, negative 4 3/4. Then it's got to be negative 4.3. So it's got to be letter A. Letter A. 4 siblings measured their heights to determine who is the tallest. The table shows their heights measured in inches. Order the siblings from tallest to shortest. So I would go ahead and just change these all into fractions or decimals. Totally up to you. I like the decimal way. So Alex as a decimal is going to be 60 point. Well, I know 5 goes into 10 times 2. So 60.6. Mia's already in a decimal form. Noah's already in decimal form. So 5 over 6, I'm going to go ahead and divide. 5 divided by 6. 6 goes into 50, 8 times. 2, drop 0, that's 3 times. So it's going to be repeating. So tallest, right, the tallest, going off the numbers, would be Mia. The next one would be Ella, Alex, and then Noah. Okay, the next one is listing them from greatest to least for integers, so positive and negative numbers. So you have no decimals, you have no fractions here. So greatest to least, so I automatically know D's out because it's got to be a positive and 18 is the biggest. Then we have 16. Then we have this 3, so A's out. And then we keep jumping, so it's got to be letter C. Kinsey bought a milk carton at lunch for $2. Represent the change in her lunch account balance as an integer. So she spent money. She's negative 2. So negative 2 would represent that situation. And then number 16, which inequality statement represents the graph below? So this is in between negative 1 and negative 2. That's negative 1.5. This one is in between 3 and 4. Oh, that'd be 3.5. So we're comparing negative 1.5 to 3.5. Well, that's not right because that's negative. Can't be that one. Can't be that one. So it's got to be one of these two. Well, 3.5 will forever be greater than negative 1.5.